All right, welcome back to the Shop Class Podcast. Tonight we got like a huge roundtable discussion all about the CNC in the classroom. Like, how do you manage it? What experience do you have with students and operating the machine? Tell us your horror stories. What do you recommend? How do you operate the software? It's all about that, and we got special guests. So let me introduce some people. We got our regulars. We got Duke, East Stroudsburg, Pennsylvania.
What's going on?
All right, he teaches middle school and he does some routing CNC. And we got Nick from Kingston area, New York, upstate New York.
Using a Schaefer origin for our CNC stuff.
Okay, nice. And we got Dave Richards from Livingston, New Jersey. He's got a Tormach 770. Am I right?
That's right. Yep. So we're in a high school and auto shop and a bunch of design classes and CAD classes. So it's kind of across the board. Yep.
Nice. And special guest straight from Tormach, Jenny Bannink.
Hi,
How
how's
you
it
doing?
going? I'm doing fantastic. How about you guys?
Oh my God, I'm so excited that you're here. Look at this. She's got the Tormach, like she's got like the home workshop's dream. Like, this is a dream shop behind you. What is going on there?
Oh, well, I got the 24R, which is our big giant router. And a very popular thing for educators right now is our XS Tech mini router. Only $4,000. And it's a little shop in the box. And then I think you had asked about our PCNC 440, which you will be getting soon, correct?
Yes.
Now,
I didn't know about this $4,000 one. I probably would have got that. No, I'm just kidding.
I would have talked you into like 5 of them. So
now, yeah, Kyle from Allegheny. We got him to sell us the Tormach 440. I thought, you know what? Give me the smallest machine, that you got as far as, it was like a full-size mill. And so we're excited to get that. And thanks for joining us, because I reached out to Tormach through the social media, and they were like, all right, look, hold on. I think we'll get somebody.
they know I'm a sucker for them. So
Yeah. And you're an educator. You go around educating people and whatnot?
Kind of. So I'm actually not a formal educator. I'm a tool and die maker by trade. And Tormach found me. I'm from northern Wisconsin, so basically Canada South. So they reached out to me, and I've been doing some STEM development because I know how important it is for industry and educators to get together because, education drives our industry, right? And so I've been working with some of the schools, including my alma mater, and I hope it's okay. I say go Northwood Bears. But I had been doing some work with them as well. And Tormach found me on LinkedIn and had a headhunter reach out to me. And they were like, you should move down to Madison. And I'm like, for what? I'm like, I don't even know you guys. Because, they were still, I've been there almost 7 years. So they were still relatively kind of newer to the game. And I fell in love with it. And they're like, how would you like to put a shop in your garage and help, teachers and educators full time? And I'm like, I get paid to talk shop and plan equipment and create educational demos. So I got the dream job.
Jenny,
Hey.
did you have shop class growing up?
Okay, so I went to a very rural school, Clear Lake, Wisconsin. When I was there, 932 people population, class of 45 students in my graduating class. We had shop class, which consisted of woods and welding. We didn't have any CNC classes. And we didn't have any machining classes. We didn't have the funding for it. And we also had small engines, which was my favorite class because I grew up as a dairy farm girl. My dad used to get me Briggs and Stratton motors from auctions. We used to go and he'd be like, that was my toy. Oh, there we go. Got a little bit. So you're a tinkerer as well.
Oh, yeah.
That was my upbringing, but yeah, no, not many shop classes, but we did have, the shop teachers that we did have were fantastic. Although there were only 2 of us. There were 3 of us, 3 girls in the shop classes, but most of us are farm girls, so it wasn't anything anyone thought of as strange, I guess. But
That's cool. That's cool. Yeah, that's our first question. Duke, give it to David. Let's go around. Real quick.
Yeah, Dave, real quick. Did you have shop class growing up?
I did. Yeah, I did. I was it was kind of cool because it was at a time when it was mostly still shop, but they were kind of starting to get into some of the tech ed stuff and design stuff. So in middle school, I actually had a whole bunch of shop classes in like 7th and 8th grade, wood shop, metal shop, and a small engines course. And I don't know which one had the like bigger impact on me. They all did. I think I was in middle school. I was like the only 7th grader using the table saw, which I remember was pretty cool. And then, in the metals class, I did really well with that. That just kind of came pretty easy to me. And the small engines class probably had the biggest impact on me. We just had to tear apart that 3.5 horsepower Briggs and Stratton and put it back together and make it run. And I have like 150 kids a year do that project now and absolutely love it. and it's really cool. So that had a big impact. And then, yeah, getting into high school was wood shop only. I think there was like maybe some kind of C++ programming, but I couldn't even remember anything from it at this point. But the high school, the wood shop class was good. I had a good teacher that also influenced my brother into being a woodshop teacher. So we both ended up, becoming shop teachers. So that was pretty cool. But again, even the other stuff, like in middle school, we did the CO2 dragster as as like a club on the side. So that was cool. So we did that sort of stuff. But for the most part, it was a lot of traditional shop classes that I loved. And then I did a lot of it at home too. So that was
Awesome.
Yeah.
So we also got Matt Garrera here. How you doing, Matt?
Hey guys, how's everybody doing?
Matt, are you a teacher at Livingston or at Madison? I couldn't figure out. I couldn't remember.
Madison High School. Yep.
And is that where is that located?
Madison.
Madison, New Jersey. Okay. All right.
Yep.
That's good.
Yep.
Okay. Well, so Duke's got the
Yeah,
main
Matt. So,
question
Matt, do you have a
for you.
CNC router?
Yeah, I have a PCNC 440, and then we have the 4x8 shop bot, and we have a Slant Pro lathe as well from Tormach.
Nice. Good. An expert. Did you have shop class growing up, Matt?
Yes, I did. So I went to High Point Regional in Sussex County. So I had Brian Drellick, Steve Peltier, Ben Kapler, all those guys.
Oh, wow.
And then when Brian got promoted to supervisor, I took his position at High Point for 4 years. And then Jason Erdreich, who was my college roommate, asked me if I wanted to come down to Madison and start the program at the high school. So then I moved down there and designed and
He's naming like the New Jersey OG crew.
yeah, I'm tied in.
Matt,
Matt, where'd you go to college?
Oh, sorry. Go ahead, dude.
TCNJ.
Matt, you got to meet Jenny. She's here from Tormach, and she's
Hey, Jenny.
she's going to give us she's got her super duper like Tormach filled garage, so it's going to be awesome.
See that.
We also got
that was my one regret when we were retrofitting our lab. We got a shop bot, and like I think a year later, you guys came out with your woodworking machine, which would have been a lot better if we had the same interface across the board.
And we just added a tool changer to the 24-hour as well.
Yeah.
So
we also I see we've got Wiston Davies. I think he's coming us from Alaska. And how you doing?
Hey, how's it going, guys? Good. How are you guys?
We've had Wiston on before. He does. He's done some like aluminum boats and some welding and whatnot. It's great. You could look in the back episodes for Winston's profile. It's cool. Thanks for joining us.
Yeah, it's been a while.
And we know Wiston had shop class growing up.
Oh yeah.
And are you using any CNC? Are you using the Tormach at all?
I don't have any Tormach. I just at the end of last school year bought an ArcLight 5x10 plasma table. So we got that. And we got a 5x10 CNC router, laser. So anyhow.
That's cool. Looks like we also got David Potts. I don't know where he's coming from, but if he wants to introduce himself. Let's see. Probably working on the sound. All right, let us jump in when you can. Cool. So, oh, there he goes. David, you there? Okay, we don't hear anything yet. All right, so let's jump into the questions. One of the concerns that I think like a shop teacher would have if I were a guest is, can you even use the machine with your students? So, like, what would be a good student designed and operated project? Can you guys go around and give us like a success story? But then you got to give us the truth. Give us the worst projects and all the pitfalls. And I think Jenny's going to jump right on this. She looks excited. Okay, go for it, Jenny. What do you got?
So, well, I was going to say, like, working with students, you got to get something. Like, I think students love useful and relevant and customizable. So I actually just whipped this one out 2 weeks ago. I was in Georgia for ISAM, which is at Georgia Tech. And so I know it looks just like a little box, but it's I don't have my cell phone here, but cell phone amplifier.
Oh, cool.
So it sits in here, but inside of it, it's also got some channels in it. So if you adjust the channel, the cut on the channel, it'll actually add, if you're adding more treble or more bass, it changes the resonance of the chamber in here. And, I did epoxy fills on these, but I think for students, like, I think, making it relevant, making it customizable, my second favorite, and then I'll have to come back for nightmares, but modular rings. So the rings actually come
What's
up.
What's a modular ring? Wait, tell us more about that.
So most of my projects have come up because of some stupid reason or another, and I'm like, oh, I could probably just machine something. So recently, in the last 2 years, I lost some weight, about 120 pounds, and my wedding ring didn't fit anymore. And I had a tungsten wedding ring, and I'm like, well, I'm just going to machine a new one. And I'm like, oh, I don't know what I want for the centerpiece. And I'm like, well, what if I could switch it out? So I made it an 8L project. And we actually did this for, I don't know if you can see, it's really hard to see, but it's threaded internally and externally.
Oh.
And you put it together, but the students then learn cutter comp, internal threading, external threading, boring, chamfering, and radiuses all in one part. And you can do different materials. So here's one of the internal pieces that you can snap in there. And because we all have different rings, they're learning stuff without even realize they're learning stuff, because each student's hands are probably going to be different sizes. So you teach them metrology, measuring your finger, and then like threading, how to do a thread fit, what works. This is a custom thread, so how to do a thread there, customizable thread. So I like fooling people into thinking that this is just a fun activity, and then all of a sudden they realize they just learned 5 or 6 different competencies. And now, like, kids in high school, romantic, I don't know if they are as romantic as when we were kids, but make your significant other a ring, or for homecoming, you could do school themed inserts so everybody has the same bling or swag. I don't know what the relevant term is. You guys are in the high schools, right?
Oh, well, not all of us, but yeah.
Is it swag now, or is it bling? Or is there some other?
Oh, probably both. I don't know. It's hard to keep up. Wait, so is that on the mill? You can cut threads on the mill?
Oh yeah, thread milling, baby. So
Okay.
Thread milling is one of those things I've always believed. So because I come from the tool making world, a lot of tool steel. And tapping is one of the last operations you do in industry on a lot of these parts. There's nothing worse than getting to that last hole and snapping a tap off, right? And then it goes right to EDM. So I learned how to thread mill right away. So now if the thread mill breaks, your part's not scrapped. But it also teaches like science, believe it or not, because thread milling, all thread milling is taking a single pointed tool, right? A 60-degree single pointed tool and rotating in a helix. And the helix is what actually determines, you know, the diameter, and the tool path's what determines the pitch. So the students are learning about pitch and diameter when you're teaching them thread milling, and you don't have to have 900,000 different taps on hand. And, you know, I just think it's a good educational tool, and you can do thread milling in a mill, and you can do cylindrical part in a mill. Whereas, you know, generally, hey, Leif, I'll stop talking. But
okay, yeah, just to introduce, Leif is coming to us from upstate New York, and he's got the Tormach 770 behind him, and he's got a whole bunch of demonstration videos and whatnot. So yeah, that makes sense that Jenny and Leif know each other. That's pretty cool. Yeah, so that's cool. The modular ring. That's interesting.
Yeah.
I never would have thought about that. That's a pretty cool idea. And what was that other one? The can you show us more details about the cell phone amplifier?
yeah, and I wish I had a disassembled one
What
right
material
now.
is that?
Whatever you want. So this one's walnut, pine, walnut and oak. And I think this one's just oak and a piece of scrap wood that I had laying around. I had to come up with the project quick. So this was my prototype, because the prototype is always going to be wonkier and not as streamlined, you know, as the next one. And the next one's going to get better. Actually, the next one I plan on making is going to have a charger built into it, a magnetic charger. So, and I'm doing a show in Las Vegas in a couple weeks, a machining show or a technical education show, ACTE. So I'm hoping to have something ready like that by then. But I'm happy to share. I have the programs ready, and I'm almost ready to share them on Tormach forums. So I'm happy to share it with you and kind of a how-to. And this is 3 different panels. So the students learn about alignment. And you can see the phone. I'll grab my phone 1 sec.
This is pretty cool.
Well, I'm thinking like kids like relevant stuff. And, you know, there's nothing worse. Everybody who's watching YouTube, like how many of you guys actually, so when I did my floors, so I did the renovation in here, I learned how to do epoxy floors on YouTube, right? Just like a normal person nowadays. But when you got your hands full and you're acid etching the floor, you're not going to want to hold on to your phone or it's going to get cracked like mine is. And sometimes it's awfully hard to hear. So you can put this on a bench, pop your phone in there. Your phone's upright. So if you're watching something, you can hear it and it amplifies it.
Nice.
And again, it's customizable. You can put your school logo on there. I feel like Vanna White. You put your company logo on there for good branding. And it's kind of a fun project that students can make their own. They can use different materials and experiment with what kind of sound comes out. So like MDF is going to sound different than pine. Oak sounds different than maple. It's the porosity and everything. And I don't know how it works because I'm not really into the acoustic part of it, but I've noticed like if you do different ones, you get different decibels, different sounds. So
it's pretty cool.
Fooling them into learning. So those are some of my favorite ones. I'm trying to think of are you talking about the worst ones I've ever done? What's that?
You got a good presentation personality and whatnot. Do you do YouTube? Because I would put your YouTubes on for my students. They would love you.
Can I tell you something really embarrassing? Between us and whoever
we're recording it. It's cool. No one will hear it except for everyone.
Hey, I'm good with it. So believe it or not, so talked about, I have a few videos out there. And it was great when Monty, I don't know if you guys know Dan Montenegro, who works for Tormach. He's our video producer. He was great because I was talking to somebody. I love talking to people. I hate talking to a camera. Like if I'm in my garage by myself, I feel crazy. Like, hi, everybody. And I'm like talking to the camera. I can talk in front of thousands of people. Giving a speech isn't a problem because I can connect with the people in the audience. I have a hard time connecting with the camera. I don't know what it is.
Yeah, understandable. That's why we do this live. Because
I know, right?
Yeah, it's more like a party. We're reacting to each other. It's much better. 100%. Well, you can jump on this show anytime. It's an open thing, and we can record your presentations. Give us like a weekly lesson. That'd be cool.
That would be fun. Because, I mean, this is easy for me, like talking to a group. But, yeah, the video part's a little scary to me.
Nice. So you got any, well, we could come back to you for horror stories.
Okay.
Yeah. Okay. Let's jump over to Leif. Leif, I gave you a last minute request, and it'll be a miracle if you pull this off. Are you thinking about making something for us?
Oh, sure. Yeah. So
Really?
you put me on the spot, but I think I can do it.
Dude, no way. Okay, so I texted him and I DM'd him and I said, dude, I don't know, but can you like design something, put it in the software, put the material in the machine and cut it for us on the show? Is that going to happen?
Yeah, but the beauty of live, I think I know what's going to happen, but we'll see. It'll be fun.
Good, we're going to screw this up.
So I'll show. I have a student project that's going on right now, so I can just like piggyback off that one because the kids have it kind of set up behind me. They're in my manufacturing class. They're slowly making as an independent project as we're doing other stuff throughout the semester. They're slowly going to make a little machinist hammer, and because there's a lot of processes involved with it. And one of those things that I wanted to get them exposed to is very simple programming of a mill. So they program it conversationally with the Path Pilot software, and then they just load a simple piece and they do a spacing cut, and then they bore out a little hole. And then the rest of the hammer they're going to do kind of with hand tools or on the manual metal lathe. But this was one of their little things they're working on. So they'll have a little aluminum handle, a little brass mallet head, and then they hand tap it. So they're hand tapping the threads in, but they cut the threads of the handle on the lathe too.
Wow,
And
that's cool.
so pretty cool. And then like Jenny was saying too, make it customizable for them too. They're also going to take the Path Pilot software, and I don't know if you guys can see that. They're going to engrave whatever they want into it. So this is Peru Tech, but they can.
Oh, there you go.
They can do whatever they want. So their initials or something. So that'll be also conversational with the Path Pilot software. The second half of the year, I have the manufacturing class do computer-aided manufacturing. So they'll do more complex tool paths with like Fusion 360. But it's neat to have them be able to just do something really simple in like 2 seconds on the actual machine, which Tormach can do. So I'll show you guys that first step.
Wait,
We'll see what happens.
just hit pause on that for a second. Let me just ask some of the guests here how much time they have. So, Dave, did you say you have limited time? Is that right?
Not too bad. I'm good. If just getting the kids to bed a little later, but I might cut out a little early, but no, don't worry about me.
Because we wanted to get some stories from your classroom, and then also Matt, if you're limited on time, we could get your guys like teacher stories about the machines, and then we could go to like Leif's like the main show kind of thing.
I'm good
So
until
maybe
like 8:20, so no rush.
Okay.
Yeah.
All right, cool.
I
9:20. I'm sorry, it is 8:20.
Oh yeah, that's true. Okay, so we're probably good. Okay, and then so Leif, you want to go for it? Are you ready? Do you need more time?
Nope, I got it. So,
Okay.
So it's
Let me
gonna
just
be-
also say Mark Willie's in the house. And Mark is the T-Stud ambassador. And he's got the Shop Class Podcast hat on. And he comes from the building science world. And he's in the Chicago area. Nice. Oh, we got
Are you going to offer those up for sale? Those
oh
pallets?
yes, I've got to get on those. Let's get them going. And we got Andrews in the house. He's from Rockland County, and he's a shop teacher, mostly metalworking. Does a lot of plasma cutting. He'll say hi in a second. Okay, Leif, Fire away, man.
All right, so they would. First, I'll preface. Jenny's a machinist. I am. I know a little bit about a bunch of different things. So
Jenny, be nice to him. All right.
No, okay. Before he starts, I just want to lay this down. Leif already knows this. Leif was like I think one of your first point of contacts, right?
that's true. Yep.
Yep. And I was like, guys, this guy has something really special. And I remember I remember we met because are you also doing robots?
Yep. Yep.
Is that right? So
Yeah, it was a few years ago now. We have never met. Actually, this is as close to face as we ever met. But
right. Oh wait, I thought it was in a meeting with you and Rogi at one point. But
oh, absolutely, yeah, definitely.
I was in a different place though. I was in my apartment, I think.
This is all like the inside Tormach Cool Club. This is Tormach Cool Club.
So yeah.
Yeah. Okay. Wait. Let me ask you a question, Leif. Can you use you have a wide view, but then you can also, if you want to, you can get your cell phone and then you can use it as almost like a GoPro, or is it easier just like this? Whatever you're comfortable with.
So I'm going to do a couple things. So one, you guys can't really see, what the kids would see on the screen when they program it. But a cool feature with Tormach is their PathPilot software has a virtual simulator too, which I use all the time and I'll have my kids use as well. So I'll show you guys what's on this screen by sharing my screen with just the simulator up.
Go for it.
And then I can probably just put my camera real close to the machine when it's going in a second.
Okay. Wow, this is cool.
We'll see how it works. All right. Who is it? Is it not going to work? I don't know.
Blinking. Is it blinking for you guys?
Yep. Oh.
I wonder why.
It doesn't like us. Here, maybe I could do. This is the beauty of a.
Oh, you know what? Don't share your whole screen. Share a tab.
Okay, let me stop.
Oh, whatever you did is good. While you're getting ready, I want to ask Matt while he's here. Matt, you got any horror stories for us?
Well, the only CNC experience that I had with anything prior to this one at Madison was my freshman year of college. So getting it up and running was a little bit fun. Tormach support was awesome. I will say that even though I think I have a pretty good procedures list for my kids, I will say I probably still snap $100 worth of bits a year, if not more, trying to teach them how to, not hit the vise, which is a lovely experience for everyone. Because then you got to recalibrate all the heights and everything like that as soon as you. So that's my least favorite part about teaching with the CNC machine. I don't have any major horror stories. There may be one or two cracks in the plexiglass on my enclosure from kids that didn't clamp things enough, or maybe myself once or twice didn't clamp things enough, or things like that. But as far as horror stories, no, I think we're pretty good. One of the things that I did a couple of years ago, one, to kind of make my life easier, and two, to make it so that if they messed something up, I didn't care as much, was I switched our main classes to, I actually brought a piece home with me. Hold on. And I sent you some pictures today of what we do.
This is good.
But I use this machinable wax.
Oh.
And you can melt it down, and I made my own molds and things like that. And now we run pretty much everything, at least the first time, in machinable wax, as long as it's, something that's worthwhile doing that way. And you can run it at 400% speed that you normally would run it at in aluminum. And it doesn't break bits if you run the bit into the side of it. It's a little bit of a game changer as far as the intro level projects. And then, obviously we have aluminum and some machining steel and stuff like that for the upper level projects. But, when you're getting the kids in there, it really is freaking awesome. And it has a lot of the same properties. It's very, I'm not going to say brittle because it is wax, but it's it's similar to almost like a high density polyethylene once it's melted together. And you don't have to run the cutting oil, so the machine stays really nice and clean. It's really easy to scoop all the stuff up out of the machine and just kind of keep it running, because as teachers, we all kind of know that, that's the other half of it. We're not machinists at the end of the day. So, keeping it clean is a little bit of a procedure, but that's one thing that I've done, like I said, that makes me enjoy the Tormach machines and the machining aspect of it a lot more. But my kids really just we make this pair of pliers. So they're they're each individual pieces. I show them how to make the pin on the lathe out of the wax. I use PVC pipe to mold the wax for those, and then it's just the same part milled twice, so that if I do it in groups of 2 or if I do it in groups of 1 or whatever, each kid gets to set one up. But we go over, like, this is it in the wax, so we go over tabs and all that kind of stuff. So that's what I do for my intro project, and then everything from there is its own ball of wax, literally, as the kids figure out what their individual parts are going to be on their projects. So
that's actually amazing. I like that project. It's something different.
Yeah, it's simple enough to, it's before we had some of the more expensive CAM softwares. I absolutely can't stand Fusion, so you'll never catch me using it ever. But before we had some of the CAM softwares that we have now, we used Illustrator. That was my first year. We literally imported the toolpaths to Illustrator and then broke them down from there. So it's simple enough where you can do it with, not a lot of software. And then it's complicated enough where it throws my second level students for a little bit of a loop here and there. So
that's cool.
Is there a CAD?
Go ahead. What'd you say, David? Sorry.
Oh, I'm sorry. Is that a CAD class or a machining class?
No, I don't do any of the CAM stuff. And my CAD class is a semester class. So by the time I get through 3D printing and laser cutting and all that kind of stuff, I honestly don't have the time to do the CAM stuff. I have the CNC machining unit in my second level honors engineering class. So we spend an entire marking period doing the first project is obviously the pliers, and then the second project, I give them a laundry list of machines they have to use to create something. And whatever that something is up to them. They can use the 3D printers, but more or less it's all about tolerance and, using the laser versus the 3D printer and combining all of those different parts and all that kind of stuff. So, we really supplement the use of the Tormach, because with 22 kids in a class, I still do find it a little bit hard to get everybody on the 440. Honestly, I wish I had. I'm sorry, is it Leif? Leif. I really wish I had the 770. If I had to order it again, I totally would. Just for the table size and everything like that. The 440 is awesome and it's really reliable, but for the size of the machine and the space it takes up, its bed size is incredibly small.
Okay, good to know. I wanted to dive into how you use Illustrator for toolpath.
It's not fun, so I'm not going to go over it with you. But more or less, you if you design a tool, you just keep doing like the offset commands with the bits, just like you would do. Honestly, like if you were trying to like absolutely brutalize your students with something like that, it's a great way to make them fundamentally understand what the CAM software is really doing. Once again, this project was enough where we basically just used the offset tool to like offset the lines that we were making out, for an 1/8 inch bit, 0.0625 or whatever. But
so your offset's your step over?
Yeah, exactly.
Okay.
Exactly. And then we ran it through basically like a G-code generator, and it, ran it through. Actually, no, we used the beta from
the DXF.
Yeah, the DXF beta.
DXF
so we exported as a DXF.
It's not a beta anymore. Yay.
Yeah, and the Tormach software brought it right through, and it worked beautifully, quite honestly. Because I was kind of in between a rock and a hard place because they wouldn't give me the permissions on the software that I wanted. So
we wouldn't?
No.
Oh, I was going to say,
My
I know
IT
people.
department.
Okay.
So we all have those stories, don't we?
All right, so I got more questions about offsets and all this stuff, but Leif looks like he's like ready to go.
I'm ready. All right. So,
Dude, take it away.
all right. So I'll show you guys the Path Pilot Hub. So this is not on the machine. This is the simulator, just so you guys can see it. But this would be what the students see. So I'll show you how the machine gets set up. But they would program to do a facing operation. So, what does that look like for the students? I like to do a screenshot of the conversational tab.
Ooh.
And then we fill it in together as a group. So they kind of have a cheat sheet when they get up to the machine, so they know what they're doing. But what you would do is we would establish an offset. I'll show you guys that in a second. I have a probe, the Tormach probe. So we'll probe a corner real quick so the machine knows where the workpiece is. But then, other features, you'd have to already tell the machine what tool you're going to use and how much does the tool stick out. So you'd establish an offset for your tool and give it a number. So I'll use a little 3/8 end mill in a second. And I'm going to machine brass. So this is where, Jenny will bite her tongue or speak up. But I'll look up feeds and speed rates with the students. And there's a whole bunch of feed and speed rate calculators. So first you'd say like what material you're going to use, what's your end mill, how many flutes, and it can spit out like a recommended chip load for every tooth. So how much is like how big of a shovel scoop it's going to take out of the material. And then it gives you a ballpark range as to what should you run your machine at for RPMs and its feed rate. Because if you're just guessing, it could spin too fast, so it takes a scoop and then it rotates and burns, or it's trying to push too much and not taking enough of a scoop. But that's like a whole nother deep dive you have to take.
That's like a whole nother 6 podcasts.
Yeah, exactly.
Feeds and speeds. We could go on all day.
So I plug those in. The Tormach forms are great. You could also just look up project examples like online, like did someone else machine brass with Tormach, and they'd probably share their little recipe. So this is how fast I'd run the tool, and I would have the kids copy that down. And then they have to plug in what is the machine going to do. We want to just do a facing operation to start. So, if I'm going to start on the upper left corner, which is what you would want to do, because the part is going to rest against a fixed jaw of the vise. So it's not going to, that could be repeatable. So we probe once and you could rotate a bunch of parts in. You don't have to keep probing their new material. So that upper left corner would be X0, Y0. And then, they'd say, okay, how far are we going to go over? Our part's an inch wide. So X starts at 0, X ends at 1. It's the upper left corner. So we want to go down the length of the part. So it's going to start on Y0, the upper left corner, but then it's going to end at Y negative 2 1/4. It's a 2 1/4 long. We're traveling down negative the part. So if you probed the opposite corner, you'd have a positive value for Y. Some stuff you get the hang of once you experiment. And you can show the kids this by just machining air at first, or just jogging it around and just watching the coordinates go. And then again, your feeds and speed rates, you want to tell it what is going to be your depth of cut and your finished depth. So we're just going to kiss the surface. So we're going to take off 0.005 inches of material. So just kissing the top surface. And that's going to be our depth of cut, and that's where we're going to end too. So that's going to be our our finished face pass.
Okay, so let me just interrupt you for a second. Super dumb question, but is this what they mean by conversational? You're like, hey, I'm at 0. I'm going over an inch. Now I'm
Yep.
going to go down an inch. Is this what they mean?
Yep,
Mhm.
exactly. Yeah, so you don't have to. You're not really like simulating your tool path. You don't have a CAD model. You're just telling the machine where you want it to travel.
Cool.
You're having a direct conversation with the machine as opposed to feeding it its own language, like the NC file. So I always tell people that you can remember that. And I love your demonstration, Leif, because yeah, it's basically you're just telling it what you want it to do, and you don't have to know all the M codes and the G codes and all that stuff. And it's great for simple programs.
Nice. That's pretty cool. Okay, what's next?
So then, after you input all that, you could say, do you want to run coolant or not? That's a little icon. Then I would post it, and you can save your file. And what I have the kids do, so eventually they're going to have a face. They're going to, bore a hole, certain size, and they're going to have an engrave feature. So I have them program that conversationally, all separate. So you could say, all right, I already made this one, so overwrite it. So then if they're going to do a pocket or a hole, I'd program that, and they'd say pocket, and then I'd do the engrave, and they save that. And then I'd have them go back and make a new file and just add all their little files together. So if you had a facing operation that's saved, and then you want to go and say, okay, after I face, I want to make a circular pocket.
Oh, I get it now. This is an orthographic drawing.
Yeah. Oh, yeah. Exactly. Yeah.
Okay. Oops.
It's not. No questions are dumb because, man, look, there's so many buttons to just get familiar with.
Yeah, I don't know what I'm looking at. I feel like I'm driving a submarine here.
Yeah.
What is this thing?
I tell the kids, ignore the bottom half when you're programming. This is just to control the machine. We're not there yet. You're just filling in the blanks. So then they'd add in all these different little conversational programs, and then they combine them all into one file by adding it on. So pending the file and making one big program. But then
it's like a layer, like, okay, face it. Now I want you to pocket it. Now I want you to engrave it. Now I want you to do a profile. So you add them up. Is that right?
Yep. And then what's cool about that is then if they didn't goof like this huge file. Maybe they goofed one little part, and then they can just go back and try to add them all together again later on. So if I go to my main screen, I just programmed a face. This would be the tool path that we're going to do. So the white
that's the face.
Yeah,
wait. How did you? Sorry.
Yep.
How did you switch it into like isometric or 3D now? What happened?
So if I went to conversational, I posted it.
Okay.
You go to file and open your file. When you go to main, you can click and drag this around.
Wow.
And what's neat is when you run it, let's just run it.
I feel like we're gonna watch the movie Tron. Is this the motorcycle? Is this a light cycle path?
You're gonna be less impressed than you were when you watched Tron. But this is simulating the path.
Oh, there it goes.
And this will go live as the machine's running, so you can watch on the screens as you go. It's pretty cool.
Leif, you gotta make some car noises for the path.
Hey, we're gonna run the machine now, so it'll make it for us.
So is that a feature request that you want me to submit to Pathpilot? Is motor noises as you're going around the corner, screeching tires for the radiuses?
I'm telling you, my students would love that, and me personally, that would be,
All right, I will put that request in tomorrow on our forum.
So when we're gonna do you guys want me to show you how how the probe works too?
Yeah,
or-
So it's like we're students. Like we don't know what's going on. I literally had know nothing. I don't.
So here's a cool thing. If you guys have or when you all get a Tormach mill, right, Jenny? When you get off,
You're hired, man.
I did. Let's see if I can see it. I took the screen and I split it twice, and I put a monitor on top of the machine.
Oh, cool.
So now, if you have 20 kids, there's only 2 people at the operating station, but we can spread out and see the simulation on top of the machine as it's going. So you make a big horseshoe. So that's a pretty cool tip. So you can see I got 2 monitors on the top. All right, so here's where you guys yell at me when you can't see, but I'll see if I can put my camera into the machine.
Just throw the whole laptop right in there.
Yeah. Okay, so I have my raw material in my vise. It's sitting up on parallels. So if you don't know, they're just 2 pieces of metal that are round to the same width. The biggest issue was that Matt was saying, hey, you don't want to hit the vise. So if you can have your material up higher than your vise, you have at least a longer delay before you have to hit the e-stop button. But we can machine up here, and we're not going to run into the vise jaws as easily. So my part's sitting up here. It's on parallels, so I have maybe like 1/8 of an inch being held in the vise jaw, and then I tighten it down. If you're new to machining too, you get a dead blow, because when you're tightening it, the part's going to want to rise up a little bit. So I like to tighten a little bit, give it a good whack, tighten a little bit more. You want to make sure that your parallels don't move. It's sitting right on them. The vise wants to have the whole thing rise up. So that's just a technician skill. I have the students set that up, so they're going to do that.
Hey, Leif, can I ask you a quick question? Not to interrupt your flow, but have you had a student throw a parallel or a part out of the vise yet?
Yes, I have.
Yes. Okay. No, I think it's good. I think it's good to have that. I mean, not for the kid, but I mean, in general, maybe you could do it every class, just to,
It's imprinted into their mind as soon as it happens. It's like a deer in the headlights when I say, oh, you got to hover over the e-stop button in case something's going to happen. And then the first kid isn't quick on the e-stop and they don't know what to do. And I say, no, hit the big red button. Nothing bad's going to happen. It already happened. Now hit stop. So, yeah.
I found a diagram.
Yeah.
Here we go.
Oh, there we go.
Perfect.
Right? Cutting the piece. You're above the vise. You got the top of it, but you're also parallel. Got it. It's beautiful.
Got it.
Nice. Okay.
Okay, so I currently have a tool in here, and I don't have it assigned. I have a tool changer on the side of the mill here. I don't have it assigned in the tool changer yet. I have the students do that later in the year when they're in the cam portion. I like to have them actually manually put the tool in and out to start, just so they get a feel for it, and they can kind of sense what's going on. So we'll take our tool out and put our probe in. I'll hang on to the bottom. And then Tormach uses it's a TTS system. So when you assemble your machine, here's a good tip I ran into is I didn't, they have great tutorials, by the way, but I didn't tighten the power drawbar enough. And the tool holder started to slip like barely noticeable amount, but when you're machining, it is very noticeable. But so it's a great system, but you got to make sure that when we assemble it, it's tightened enough. But that is clamping down on our tool just like that.
Is it a power drawbar or is it just a manual?
So this one is a power drawbar. If you're going to get the machine, you have to get the power drawbar because it'd be so annoying to manually unwrench it. You wouldn't want to use the machine ever. You don't.
Hey,
Yeah, go for it.
Oh, sorry. I don't want to interrupt you. I was just going to mention, I know that you're getting a 440 shortly. Do you have the enclosure?
Yes.
Did you get a power drawbar?
I got to look at the sheet. I don't remember. Good question.
Okay. So, and I have an enclosure for mine. I'm putting in new ball screws and a spindle. I have serial number 3, and I'm giving her a spa day. And so that's why she's kind of stripped down, no bellows and stuff right now. But when you have the enclosure on, if a student forgets to close that spindle door, you're going to know because it's a fully enclosed enclosure with the slits in it. And you're going to hear ka-chunk if they go to manually drop the Z down. And it's just one of those things like that you should be aware of. The power drawbar kind of helps you prevent having the kid forget to leave the spindle door open. Kind of like when you're in school and you're learning the bridge ports and you forget to take it out of neutral. And you only do that like once or twice because everybody stops and looks at you. But just so you know, one of those little things to keep in mind, remind the students to always close the door. I always tell them, keep your hand on the door. So
Yeah, I may know what you're talking about with that.
yeah.
Matt, I've got the mill, the stand, the chip pan, the enclosure door switch kit, the path pilot controller, standard LED jog. Is this a lot of stuff?
No, you got the power drawbar right there. See?
Oh yeah, that's what I'm talking about.
I'll have you know, Kyle's one of my reseller guys. I work with our resellers quite a bit, and he's not going to do you wrong. He's great.
Ooh, extended warranty. That's what that's what I need. Machinist owner's kit. Okay. Sheenway oil, waterproof mini keyboard, and waterproof mouse.
We need the lifetime warranty.
Yeah. Let's see. What's this? Quali Chem. Oh, that's just for cutting oil or something?
Yep.
Cutting tool starter set. Oh, good. 3D sensor. Whoa.
Oh, I hope you have extra tips in there. I think I saw them at the top.
Oops, I did it again. Warranty. On-site assembly. So I get to meet some people.
Ooh. Oh, well, you went through Allegheny?
Yeah. Yeah.
Yeah. So
I was like, man, you can't just drop this off, dude. You got to set this up and you got to train me. I don't got time for you to drop a box in my room. I already got a bunch of boxes there. On-site. We got the whole shebang. So hopefully, is that enough?
Oh, I think so. Let's see. How much tooling did you get?
I don't know. Does it take an R8?
So that I'm actually glad you asked that. So you got tool holders, right? Do you have something called the TTS operator set on there?
Oh yeah, here it is.
Okay. Yep. So, oh man, I mean, I don't want to like bore you guys with a bunch of stuff, but
wait, this is the show.
Okay, show and tell.
Look, I love dorks. We're doing this.
Sweet. Okay, because you don't want to get me going if I start talking shop. Because if I start talking shop, I never stop. Ask Leif; he knows I'm a chatterbox. But I geek out about how stuff is made and put together and all of that. I remember we were talking earlier about the Briggs and Stratton stuff. This is my jam. So,
shaft right here, man.
Yeah. Oh yeah, you got your chop saw there, or your not chop saw, your right there. Okay, it was a little fuzzy. The cam for the there.
Briggs and Stratton. We got parts. Yeah, no, you're in the right spot. This is it.
All right.
Podcast. We nerd out on this.
So all of us, and I know I'm glad you asked the question at the beginning about how many people took shop class, because a lot of people, have ran a Bridgeport, at least at some capacity, if you've taken shop class. So Bridgeport has, and you asked about an R8 collet, right? Yep. So inside the spindle is a drawbar, and I'm sorry if you guys already know this, but this is a drawbar. All it is a threaded rod, right? And so this threaded rod goes down in through the spindle, and we have our adapter collet. Now, when Tormach opened about like 20 years ago, this year's our 20-year anniversary. there wasn't a lot of options for, hey, I want to get a Cat 40 or a BT 30 in my garage. So they were like, well, our design is very similar to a Bridgeport design when you think about it. It's dovetail ways, ball screw, it's ball screw driven, very simple with angular contact bearings, double nut kind of design. Same thing with the spindle. The spindle's like an R8 collet here. And so you take the R8 collet, and are you guys familiar with our tool holders? I know Matt, or no, this is a BT30. Let me grab a different one. So our TTS tool holders, if you have a Tormach and you have a power drawbar and or tool changer, chances are you have one of these guys. Well, back then, Greg Jackson and Ed Korn, who started the company, said, how about we just keep it simple, the old KISS method. Keep it simple, stupid, right? So you have an R8 collet, which normally you would have a whole slew of these, right, on a rack. And you would grab the diameter so you could put your tool in. So this would be like a 3/4 inch diameter. You'd stuff the tool in, touch the tool off or kiss it off on the top of the part, and then get going, right? Zero out your DRO. But we're like, well, wait a minute. That kind of sucks because you can't use a tool changer. You're changing them out one at a time like you do with an old school router or Bridgeport. And they're like, wouldn't it be great if you could have a predetermined touch off for your tools? And so it sits against the tool nose each time, so you're not having to measure each time. So they designed our TTS tool holders. And it's a straight shank tool holder. Basically, it's like how a Bridgeport would hold a regular tool, only it's holding just this stem here, and this ground surface touches off on, oh, there we go. Oh, thank you. Yeah, so you got the granite block. That's how you basically keep it simple for the students to learn. This is where I really like how visual it is. So when you look at that granite block, and I have mine here that I use quite a bit. Again, I feel like Vanna White. And just so you know, I'm not a salesman.
No, it's all good. This is cool.
But, so you have your granite block there, and you have your TTS tool or your tool in your TTS tool holder. Eventually, we'll get to the different ER columns.
Is this to determine your offset?
Yeah, your length, because in the machine like Leif has, the R8 spindle, you're actually measuring, this actually sits against the spindle nose, right? So we're going to pretend that this is in the machine and it's up against the spindle nose. This dimension's not going to change. So it's actually going to be out here. So this actually sits against there. But each time it goes in there, this surface sits against the spindle nose, and this is sucked up against, I don't know if you can see that or if it's fuzzy. But yeah, so you're going to have the same length each time this tool goes into the machine. I wish I had my camera set up over here. Maybe we'll do a show and tell sometime. But yeah, so it sits up in the machine. Oh, wait, you know what? Leif's got his machine. Do you want to, I think we could probably see, just so you can see, you have a tool holder in there, right? Or do you have a,
so I just,
oh, you have,
can you hear me? I just put my probe in.
yeah.
Oh, cool.
So
there it is.
Yep. And now the next time he puts it in, it's going to sit in there the same way because this sits against the spindle nose. And what you're actually teaching the students here is that this back part, granite block is a measuring standard, right? So, you're going to touch off, and we try, this is a very simple system, but I like it because it teaches what you're actually doing, how you're communicating with the machine. So like here, we've got, your height gauge, you zero it out on the granite block, and then you put your tool in here. All right, I need bigger hands, but you put your tool in here. So you're zeroed out here, you touch off here, and you're teaching the students that when you're putting the length in, you're actually just telling the machine that between the spindle nose and the tip of the tool, this is how long it is. And So if you swap out tools, for example, if I decide I'm going to swap out and put in a half-inch tool and hang it out 1.5 inches, that's going to change in the offsets. But I mean, it kind of helps them recognize that, hey, you know, like tool 1 is this little short one and tool 3 is much longer, and you can see that in the numbers. Perfect.
Yeah, so every time you change the tool, you got to measure the offset relative to the end of the spindle, and then the way you do that is stick it on the granite block, which has a place for it, a placeholder.
Yep.
Pretty
and it's
cool.
great. And I like it because you can have another student measuring their tools and writing them down or whatever. So, you know, I think one of the biggest issues, and correct me if I'm wrong, because like I said, I'm not a formal educator, but you know,
I got news for you. Neither are we. This is a shop class. We just like make it work.
Well, you get the kids in the big line. Oh my gosh, you guys freaked me out. I thought Rogie was joining us. No, I love Rogie. He's great. I'm like, our CEO's in here.
I didn't even realize. I just pulled up a video that I thought was good.
Yeah, actually, that guy right there doing the video, he's the CEO of the company now, and he's one of the first architects of our Path Pilot controller, which is, cool. If you guys are computer gurus, I'm not a computer guru, but our control software is Linux-based, open source software, and we're firm believers in open source, right to repair, kind of the whole community thing. So,
Leif, go horizontal if you can. And then also turn off the sound on your computer. And if you talk, see, I know it sounds funny, but if you talk, that your video will be the main one being recorded. Only time, even though you're seeing everybody's screen, it doesn't record. Only one of them.
Oh, there we go.
Turn off the sound and everything. But anyway, it's complicated, but you'll figure it out. Basically, it'll only record the one where you're speaking. So go ahead and give us a tour.
And he's got that Saunders Machine Works plate. Love that thing.
Go ahead and talk on that, Leif, and we'll it'll go to your screen. Okay, you got a feedback issue. Okay.
Can you hear me?
Yeah.
There we go.
Can you hear me now?
Yes.
All right. Okay, so you guys can keep going and talking if you want, and I'll just start a probe if you guys want to see it start to record.
No, go for it. You give us the tour. Go ahead.
All right. So I am gonna tell my machine that I have the probe in. I probed it to tool 99. And then I'm going to go to my probing cycle. And you can tell the red dot's where the probe is. And then the gray shaded area is your part. So I can see that's my part right there. And I'm going to hit the probe X. So you can see the red dot's going to go over. And then I'll jog it, and I'm going to probe the Y. So then I'm going to probe my Y. Red dot's the probe going down to my part. And then I'm going to jog it up and probe to Z. And then you guys can keep talking now, but now the machine knows where the material
is initially located.
Okay, so I got a question. My imagination told me that you automatically did that. Like it literally stopped when it hit. Is that what happened?
Yeah, so I have the Tormach probe. It's hardwired into the actual machine. I already set it up so it knows how big the probe is. So then it'll read that as a sensor, and it can know where that piece of material is. So it's way more accurate than the by eye method for sure.
Doesn't this make it like super convenient? That looks amazing. I didn't realize that they even had that as an option.
Yeah, it's pretty cool.
Hey, Leif, at this point, what is a common mistake that people make? Because you're telling us everything to be effective, but what is a mistake?
The mistake is, as a teacher, walking away from the machine as a student is probing by themselves. Because if they hit the wrong button, they'll probe the opposite way. So you don't want that to happen.
That's amazing. That is such a cool feature. I didn't even know that was a possibility. Okay, cool. So now you're probed. So you got all your zeros now, right?
Yeah. So now I'm going to I'll have to take out the probe. So I'll Z up. Hey, here's a common mistake: is going Z the wrong direction. So there's a bunch of mistakes here. I'll take the probe out, and then I'm going to load my file. This file was so it's made by the students already. I'll load it. It's made conversationally. You guys can see the tool path. And if I rotate it so it's a little isometric view, it's going to face, which I showed earlier, but it's also going to drill a pocket down. You could do this a lot of different ways. Jenny, you make fun of me later. It'll be very, very slow. I found that it's such a deep pocket for the end mill that I'm having the kids almost like peck a little bit and bore it out to the right diameter and then go up so it'll retract. And when it retracts, it'll allow my mist coolant to just clear chips away so they don't build up. I don't have flood coolant on my machine. I don't know what you got. I got a mister, which is great because you can turn off the coolant and just, if you're cutting wood or foam, it'll just use compressed air and blow it away. Or you could fine tune it and mist coolant from the back. But it has its minuses too. So
I found the probe.
Yep, that'd be, or one of their versions of that probe.
It's pretty cool. Nice. Okay.
Yeah, and that one's the active probe, which I think is considerably more than the passive. And they do the same thing. It's just that particular model's a hair bit more accurate. But for education, I mean, the current one that Leif has is outstanding. And I think it's under $400 or $500.
Oh, yeah.
So
Yeah, I just found it. Here it is.
there you go.
All right, so I'm going to awkwardly set my phone down for a second and change out the tool from the probe to the actual tool we want to use. But I need two hands.
Okay, Matt, thanks for joining us. Matt's going to take off, man. See you later. Stay in touch. Okay, so he's changing the tool now, and it's an air operated thing, I'm guessing. So it's like,
Yeah, so it's pretty cool noise. So so I put in tool number 1. So I'll go back to my controller, and instead of tool 99, I took the tool out. So I now tell the machine I have tool number 1 in there. And in the conversational, we already said what tool we're going to use. Where is that tool located? Like Jenny already demonstrated, I had it labeled and told it the diameter and the length offset. So the machine knows what tool number 1 is. And you can see these fill up pretty quick. So then you can see in the G code now that's generated, tool number equals number 1. What's cool about the Path Pilot software too, though, is if you put in a different tool, so say I had tool number whatever, 3 in here, it'll stop me right when I hit start and say, hey, you need to insert tool number 1, because it'll go down to that line of code and say tool number 1 is not there.
Cool.
That's the
Right,
difference
so-
between using industrial tools when you're asking yourself, what did I use last time? This is telling you what you're supposed to use. It's like a friend that doesn't forget.
Yes, and it'll give you gentle reminders.
Nice.
So now I'll run it. I'll run it with the doors ajar. I don't do that with the kids, but you'll get a little better view. It's going to mist coolant out here. And what you're going to see off screen is all I'm doing is hitting cycle start, or I'll hit it on screen. I'll do cycle start. And I have the kids say, even if you ran it 8 times, hover over the emergency stop button in case you did not clamp it down properly, or, who knows? Because we're not really doing production. They're doing one at a time. So let cycle start.
Ron, can you full screen this?
You can press the pin.
And Leif, I was going to say I would never make fun of you for going slow. I always tell people, go slow, because I think it makes students more comfortable too.
So I like this feature. It's in the settings too. It's an optional stop in between different tool paths. So it gives you time to check to make sure it's still working right, or whatever. Maybe you're clearing chips, and you can see it just it did the facing operation. And then I'll just start the next cycle, but I'll pause it after it does a couple seconds, because Jenny will make fun of me how slow it's going to go, but it works, Jenny. So I'm not going to argue with the results.
I just said I would never make fun of you. I always tell people, everybody's.
Oh, wait till you see how slow this thing goes, though, Jenny. All right, so it's going to do the hole that they're eventually going to thread with the tap. So they had to look up, what their tap size hole was, and we do through that whole process. So that's kind of fun too. But they're going to hand tap it, not going to do it in the machine. So I'm going to hit cycle start again.
Ooh, I see the chips being shot out of it.
And can I just say, as someone from industry, I just want to tell shop teachers everywhere to stop weirding out about feeds and speeds. It's okay. Start with something simple. And if you throw a part or if you blow up a bit, okay. Oh, I was just going to say, pro tip. If you want lots of gently used tips, reach out to industry. And it sounds like a lot of you guys, the way you say button, are on the East Coast. So, I was going to say, you guys have a lot of industry up that way. So if you have students whose parents work in machine shops, say, hey, tell your boss for a tax deduction if they donate their tooling to the local school. Their business can actually get a tax deduction. And some shops won't reuse carbide after a certain amount of time. Just a fun fact. So
good idea. And that was awesome. Yeah, I mean, it's kind of not fair when Titans of CNC is out there. You ever see their videos? They're like, you're not going fast enough. Faster. They're like, you could see the chips coming off, and they're like flame. They're like, like they're bit. Like all these carbide things. You know, I was like, oh my God.
And I'm sure your administrators love that, right? When they walk by and the machine's on fire and
yeah, well, yeah, exactly. Slow and low. That is the tempo. Yeah, that's what I tell the welders. But so that's awesome, Leif. Thanks for doing that. That's pretty cool. And was that a threading operation, or was that just the hole?
So that was just the hole. And, and then we run into limited tooling. It should be just like a drilling operation, but I actually don't have that size drill. So we have an end mill. We're gonna mill it out. Works fine, but it also gives a chance the kids get to see actual chips flying off, which is pretty nice. And then again, it's like 2 kids are doing that every class. Slow, long-term project, so it's fun for them to see it for sure.
Do you have the ability to tap with you know what I'm talking about?
So I haven't tried a rigid tapping. I'm actually not sure if it could do that. I have done, there's thread milling, which is pretty cool. You can actually do that conversationally as well through the Path Pilot software. And that it's a little scary the first time you do it, because you would drill out a hole, or carve out a hole, and then your thread mill, it almost looks like a lollipop, and then it plunges down all the way to the bottom of the hole, and then it cuts the threads going up.
Oh.
But that operation where it goes down to the bottom of the hole, the first step, you're like, you're clenched. So
wow.
And then it looks like it's going to plow into the wall, because the first lead in, so it drops into the hole and it starts ramping out. It's kind of invigorating too, though. And
cool. No, it's very stressful.
I could answer your question about rigid tap if you want, real quick.
Yeah.
So unfortunately, the 440 cannot tap at all. This is something that's really important for people to know. So it doesn't have a reversible spindle at this point. And so it's an R8 spindle. It knows forward. It doesn't know reverse, but you can thread mill with it. And I encourage you to thread mill with it, because really the horsepower on that spindle, it's a great spindle for milling and cutting operations. But when you think about threading, it is archaic. You're drilling a hole that's undersized, and then you're taking another tool that you hope is sharp enough to make it through without dying. And then you're plunging it into the hole, and then you're retracting it. And so with the M, though, the one that Leif has, he can tap, but with the tension compression tapping head. So, and the reason for that is actually the spindle. So we have that R8 straight shank spindle, and then we got the BT30. And most people who work in industry are used to seeing this tapered tool holder. This is an industry standard tool holder. You'll see on the sides that there's these little cutouts that you call drive dogs. Basically, the drive dog is there, so you put it in the spindle the same way each time. And so when you put it in, so I'm going to back up really quick to the 440 and Leif's machine. You've got this, when I was talking about the Bridgeport spindle, the spindle knows forward, it knows reverse, it knows the RPM, this is all being fed from the VFD. It knows how fast it should go, and it knows what direction, and it knows stop. But it doesn't know where it's going to stop in rotation. So this is spinning, and you're going to hit stop, and the spindle doesn't have feedback. So the spindle has no idea where it is. It's kind of like, remember the baseball bat game where you put your head on the bat and you'd spin around, and then wherever you end up, you end up. kind of like that. It has no idea where it is. The BT30 spindle has an encoder, which basically it's a communication link between your controller and your spindle. So it knows where it is within the rotation, which is important if you're doing rigid tapping. All rigid tapping is being able to put a tap into a standard spindle and then tapping all the way down, then tapping all the way up. But there's no give in this holder. You know, if you have a standard holder, there's no give. So what happens is if you plunge down and say you're going, I don't know, a quarter 20, and you're saying, hey, I'm going to tap this quarter 20. I'm going to go down 3/8 of an inch, and I'm going to stop, and I'm going to reverse. And it's a blind hole, you know, so not a through hole, but a hole that stops at a pocket depth. The problem is if it doesn't stop at the exact same spot, and everybody knows that the size 6 taps are the worst because they have those skinny little necks and torsion, you know, and all of a sudden you hear ping. Well, that happens because there's no play there with a rigid holder like this. With a tension compression tapping head, and we have a couple of varieties of them, but we also have like an ER20 style, which are the ones I recommend because you can use those little collets you see right by the red wrench. We can talk about collets later if anyone has questions. But so with the ER21, there's actually a little spring. There's some give in it, so it doesn't matter if it doesn't stop exactly because it kind of like throws it into neutral and it gives it a little gap. You know what I'm saying? So give a little bit of give, and then it lifts up and it's not going to snap off your tap because it gives it a little wiggle room. But with the encoder, it'll say, I want to tap 3/8 of an inch deep, and I'm going to stop at 127 degrees from 0. The controller knows where the spindle is because when you put this tool holder in there, it knows where it is according to these dogs. These dogs are going to be the same on the spindle. And when you turn on the machine, it does a little dance. People like, my spindle's doing this little like shimmy dance. And it's like, it goes, it's orienting. It's basically the same as referencing. It's just telling it where it is in space and in rotation. And sorry, I probably got a little too.
No, it's perfect. Wait,
I love this stuff.
Is the encoder, is it in the actual BT30, or is it that it's just that it's keyed, and because it's keyed, it knows where it is?
That's it. It's keyed.
Okay.
But yeah, so
gotcha. Pretty cool. So this is it right here, basically, right?
Yeah, that is an ER20. Yep, that's an ER20. I can do a real quick rundown and I'm not trying to like steal your show at all.
No, you're on the show. You're on the show.
This is a common question I get. And I actually had this conversation 3 times, and I work predominantly with tech ed teachers. And they're like, well, what's the difference between an ER20 and an ER30 and an ER16 and an ER40? And it's just size. And so, you know, I don't know if anyone is used to the ER system, but we have here like this split collet. And I know, I'm sorry, I'm going to have to get a better camera system here. But if you've seen collets like this, they sit underneath this nut. And if you look, that hole is not centered. It's okay. It's not manufactured wrong. This is an industry standard system. The collet's designed to snap into a little undercut that's inside that nut. You never put it straight in. You drop it in and click it in, and it sits under there. And then your tool goes into this hole, and then you tighten it, you know, onto the holder. But the size difference is ER16 goes, you know, from the smallest size, which could be like 1/64, whatever your collet is. You can get a collet set too, and I usually recommend that because it gives you some versatility. Because you never know, if you do end up with donated tools, you could get a bunch of 3/16, 5/16, those off sizes. You know, you might get some metric, you might get some standard. These collets give you about, I want to say 15 thou per side, or 30 thousandths of squish. So you can hold, you know, some that are close to that size. But yeah, so the ER16 goes up to 3/8 of an inch, ER20 goes up to 1/2 an inch, and ER32 goes up to 3/4 of an inch.
What do I got here?
That is a set screw holder, or for those of us in industry, kind of like tissue Kleenex, a weld-on holder. So you're actually, if you look at that, I wish I actually might have one. It's going to be an R8. And sorry, things are dusty.
We can't see the dust.
Okay. I was going to say embarrassing story. So, I mean, I was kind of informed I was doing this like pretty short notice this morning.
Oh yeah, sorry. Yeah, that was like.
No, that's okay. And I was working all day and I was making stuff in the router, and it's cold here in Wisconsin. We have snow, and I didn't get a chance to get my shop swept up. So
We are
don't look
judging
too close.
you very harshly.
No,
because,
but
this place I'm in is like perfect. So
well, I was gonna say, don't tell my mom, because I did the worst thing that you should never do. And I was like, okay, I grabbed my air compressor and I just blew all the if my mom would have given me an air compressor when I was a kid, that's how I would have cleaned my room every day. Like everything, just papers flying, but I kind of just don't look behind the whiteboard. Did a real clean. So
it's all right.
but
You're in big trouble. Leaf blowers.
just there, I have one for my shop. My father-in-law, Gary, that was a housewarming gift he got me. And my husband's like, I don't need a leaf blower. We have rakes. And he goes, it's not for you. It's for her shop. And I'm like, I love you. Like, if you have good in-laws, you know that life's going to be great. Because I'm like, they got us a leaf blower for my shop. And I'm like, that's amazing. My husband's like, really? And he's like, the air compressor is not enough. I'm like, well, not always. And it's loud. And but anyway, just don't tell my mom that I'm still sweeping stuff underneath, well, in this case, the router, but at home it was under the bed.
Well, speaking of like sweeping away dust and chips, what about if you use let's say wood in the mill just to get started? Is that a problem for like the ways or anything like that, the cellulose and all the stuff from the wood?
So not really. The thing you want to avoid doing, and you hear so many people like, oh my gosh, I can't believe you cut wood in your mill and it's going to melt down and the world's going to end. It's not going to end. And I actually encourage people to use wood. You know why? It's cheap. It's readily available. It's not, if a kid crashes into the wood, it could bust the tool, but chances are it's not going to. It's readily available. It's, it comes in a variety. You can do all sorts of fun things with wood, and it's very forgiving. So you don't stress them out. I think, and this is not just for students, but people who are new shop teachers that maybe didn't go to school for this. I think this is really important. I think that it's unrealistic to expect a teacher who does not come from industry to teach an entire class to be professional machinists in 8 to 12 weeks, because it has taken me years, and I've been in CNC since 99. I started in lasers, and I'm like, you don't want to overwhelm the students. Don't stress them out with all the formulas and everything right away. Get them making something fun first, and then they'll want to learn more, because then they're going to want to do more complex stuff. But yeah, as far as the wood, get a shop vac, a nice shop vac, and make sure you just clean it out good, or make your kids clean it out good, and then wipe it down. Teach your kids to clean the machine if you're allowed to. I don't know if they have to have tetanus shots or anything for shop class. But it's not going to hurt your machine. You have bellow covers for a reason. You have, there are things. If you're going to be cutting predominantly woods, then you're probably going to want a router. But if you're just learning, it's not going to blow up your machine.
Cool.
And I think that sometimes people they're like, oh my gosh, because they're kind of machine snobs. And that sounds horrible. I shouldn't say that. It's not going to hurt. In an educational setting, you're not making molds. You're not making injection molds. You're not worried about a 1/10 or 2 or getting wood pulp. Your biggest concern is just not getting the wood pulp in the coolant, especially an organic coolant, because then it gets stinky. But
I want that's great. Let me give. I want to get Dave what he's doing with his David. What he's doing with his machine. I'm sure he's broken a bunch of bits. Let's hear the horror stuff first, man, so we can make Jenny laugh.
I gotta be honest. It's so I'm this is a little bit on the newer side to me. The machine. Oh yeah, there it is. That's in the shop over there. So I actually moved it to a different location after that because we sort of started to build up right off the shop. There was a storage room. We all kind of gave up some storage and now it's like a maker space. So we got it's next to like a smaller shop or Shark like CNC router. And there's the shop. So it's so we moved it to a different spot that gave us a little bit more room, and it's actually some other classes that are using it also. So it that's a good thing. We have not used it a lot. I gotta be honest, it's newer to us.
Leif, thanks a lot, man. Leif dude, I really appreciate the demo.
Yep.
That was amazing. You did awesome. Like I said, you're hired. We're gonna steal you from your school. That was a great demo. What's that?
Thanks. I'll talk to you guys later. Nice seeing you.
All right. Thanks, Leif. See ya.
Bye.
Cheesy.
So it was, what I can kind of speak to is just getting started with it. We had it for a while. It was actually a former supervisor of ours that kind of pushed for one of those items that has to be in a makerspace, like we wanted like real makerspace. And it was, we're big into robotic stuff, the first robotics. So it was a way to, I think we actually kind of shared some grant money and things to get it. And I think one of their first visions was to be able to actually cut out like the full chassis, like an 18 by 18 chassis. And, as we found out that it's not really the best machine for that. That's more like a plasma cutter or a water jet or something that would cut out from a sheet of aluminum. But we started playing around here and there. And then again, the pandemic hit, we weren't in, we lost touch with it. And now we started again. There's actually another former tech ed teacher, Adam Brunner, that was a teacher in New Jersey for a while too. And we bump into him here and there, and he always pushes us and come on, you got to get that thing going. and ironically, so some of the towns around us, also Milburn and Madison, who was on before, they are a lot bigger with it than us. But our visions with it, is this engineering class that we're kind of rewriting the curriculum. So we're hoping that the kids can just go through all the machinery, the laser cutter, like CNC router, the 3D printing. We just sort of the plasma cutting, and then this as well. So we do a lot of Fusion 360. So it's new to us. We have one student that's one teacher that's really taken this on as their kind of thing. I could probably share a picture. I have not necessarily cutting anything, but let me see it.
What do you think? Because that is one of the fears of getting a machine like this, that it'll like sit and wait if it gets too busy or it's not the right application. What do you think happened in the beginning? It wasn't the right size or the application?
No. So, good question. It's and it's other people I've heard this as well, that they've kind of got it. They were maybe somebody pushed them to get it, or somebody wanted it, but they just didn't understand the learning curve behind it. So by the way, ours it's the PCNC 770, and it's the full enclosure, coolant, all that stuff. I have broken a couple end mills, jammed one like right through the 2x4. The initial project, when you read in the binder that comes with it, I figured like, all right, I'll learn this. I'll just read this Pathfinder, like example sort of project. And it was, I said something wrong and just sent the end mill right into the bottom of it. And I think somebody else did that too. And it took us a little while, but so the learning curve, we expected to kind of get it and hit the ground running. And I think, for tech ed teachers or for any teachers, they need some time. You know, the way that we learn something, like when we first got the laser cutter, is I got to be obsessed with it. I got to go home and watch a whole bunch of YouTube videos and then get in there and try it and whatnot. And I think we were all sort of just doing other things. So it wasn't like the guy that got it for us initially wasn't, you know, it was his passion. It wasn't ours. And we're like, oh yeah, we'll get to it. We'll get to it. We'll get to it. And we knew it was this, you know, everybody would walk in the shop and be like, oh my God, this thing's awesome. It's great. And we're like, yeah, it is, but we just don't know how to use it. You know? And
that happens. That's good honesty. That happens to me too. All the shop teachers, you know, you want to order something and then you get it. You're like, oh man, I don't have the time for this. Or, you know, or like, did you know Jenny before tonight? You didn't meet her, right?
No.
Yeah. Well, Jenny, where were you on this one? Huh?
Well, did you buy from Adam Brunner?
Yeah.
When you said Milburn, though, I actually did Milburn's installation and training. Oh
Okay.
my gosh, beautiful school.
Yeah.
I think I've traveled to New Jersey the most for work. They're like, Jenny, go to Jersey. I'm like, I'm not a Jersey, you know.
So I don't blame you. Me.
No, actually, I love it there.
It's got everything. It's got everything. It's just it's got its ups and downs too. But it's a good place to be. But
I love New Jersey. It's very green.
Awesome. So Milburn is real big with robotics too, and I think they have a couple. They were real big into computer science. And, you know, again, it's a certain kid that's going to do this. I struggle. I teach mostly auto shop now. And we originally put it in the auto shop, hoping that we could get this group of kids some skills that they can go right into. I mean, everybody wants CNC operators. Like you see it all over, you know, practical machinists and all these different forums and signs. I see it when I'm driving down one of the highways in the factories. They're looking for CNC operators. So we figured some of these kids that just sign up for the class and they're not crazy about working on cars, they just want to be in a shop, we can get them that skill. So that was our goal. We struggled and we're still doing it. And that's where the conversational piece comes in handy, that you can just kind of get them moving, doing, and that's where I'll pull a group of kids over and kind of show them in a facing operation or something like that. But we've discovered that it needs to be more so in the engineering class, because you need to be able to, get those kids to sit in front of the computer and teach them a little bit of speeds and feeds and just this whole program. Mine having a lot of kids in one room who are, you know, this is their class, is sort of their break for the day. It's a little bit challenging to get them all this information for them. So, you know, that's my struggles, but I think as we combine it, we thrive off of those couple of kids that just say, hey, what's that? And oh yeah, I heard about that and I really want to do that. And we all have those kids, you know, they're in an upper level class that's combined with a first level class, or they're just hanging out there during lunch and after school. And those are the kids that sort of jump on it and say, hey, I'm going to master this thing. And that's what we support that. So we haven't had that in a little while, but we're kind of getting back to it too. I ran
Oh my
more.
gosh.
Sorry.
No, that was great, actually, David. That was great because it's almost like a sound bite. We put a timestamp on it. You were on a roll there. That was good. That was good fire right there.
Oh,
yeah.
I thought it was
Go ahead,
perfect because I've had teachers who, you know, like they're like, oh, I'm going to save money, and maybe they're not as fancy. They don't have the installation and training, but they're like, I'm going to have the kids put it together. And I said, perfect. And I'm like, you're going to have the most like motivated, like construction crew ever. Cause these kids, they want to put it together. They want it now. Cause they're watching it they're on YouTube, watching YouTube. They want to make lightsabers. They want to make this stuff. And you do get those kids that are so inspired. And I think using them as leadership to also teach you something is so important. Cause anytime I do a lot with First Robotics as well. I've been to the last like 3 Detroit competitions, or no, maybe 2, because the one got canceled, and running in the machine shop. So Tormach's was one of the sponsors to the machine shop for, I think I've done, was my 5th year. But you get those students that are just so excited and invigorated, and they're going to teach you how to run the machine. So that saves you hours of YouTube, so you can watch this old Tony instead of
This comes up every so often. Just like 60 horsepower machine on titanium you're just ripping through titanium, just insanity.
Awesome.
My students haven't brought this up to me at all, but this is pretty popular going on right now. This is just, that's a facing operation.
And they don't the tooling is going to be a little more expensive than you probably want I don't know if you want the kids.
Oh yeah. Oh yeah. No, this tooling is like just the end mill itself is probably more expensive than my entire shop.
Ron, if I could, Jenny touched on something before that was it was interesting. You said everybody worked on a Bridgeport mill at some point, and I think we all did, and I did. And I went to Millersville in Pennsylvania, which is a little more rural area, and spent a lot of time at a Bridgeport mill there, and enjoyed it a lot. But part of my issue too is I can't say that about my current students. We don't have a Bridgeport. We jumped right into this, and and that was tough. There used to be a big metal shop years ago, but that's actually one thing we're doing now also is to just get some smaller kind of basic mills, so that we could get the kids kind of just milling wax blocks, just to get used to the X, Y, and Z axis and what you're actually trying to do and accomplish with this. But to see it by hand, I feel like we have a good concept of it, but every time I try to teach it, they don't really understand what I'm doing.
This one works really well for me.
Oh, all right. Yeah.
This is the Jet. It's kind of teenager proof.
Okay, that's what. Yeah.
We haven't
like the
destroyed it
hardest
yet.
ones are not.
No, and
but you don't put an end mill in the drill chuck, right?
No.
Okay.
It has an R8. Yeah, it has an R8 collet, and it's got a whole bunch of collets that come with it. It's got a stand. Stand is the cheapest stand they could possibly make, but it does work.
Okay.
You put it in with it, hoist it up with an engine crane. All this stuff is just belts and pulleys, like a drill press thing, and you can actually do stuff on here. And it's only like 2,300 or maybe it's like $3,000 with everything. Oh, and you can get a digital readout too.
Oh yeah, okay. Oh
yeah. So maybe like $3,000, you got the digital readout. This thing's great, and now we're trying to graduate. So I would take, like you said, I would start the kids on manual, 100%, because they don't have that mill. And I don't have a Bridgeport. The shadow for the Bridgeport is there, but
it's so sad, isn't it?
dude, it breaks my heart. Go ahead.
People, it's funny. I think every high school had them, every shop had them, and people snatch them up now, and now all of a sudden they know what they're worth, and they're hard to get back.
So, go ahead, Jenny.
Oh, sorry. I was just going to say, and this is great because concepts like peck drilling, if you just say the word peck drilling, the kids, well, first of all, they giggle. And then second of all, they're not understanding that you're actually breaking up the chip as you're going down the hole. So if they have something like this, they understand it then when that translates over to the CNC. Same kind of thing. Like, I'm so glad you brought this up because like conventional mill versus climb milling, when you're trying to describe it to someone, even I have to stop, and it's like patting your head and rubbing your belly and then switching. It's kind of like trying to explain that concept to someone who's never ran a manual, where you're like, you can feel it, climbing you can feel it climbing the material. Well, if you've only done CNC, it's a really hard thing to visualize.
Mm-hmm.
And
Yeah, like I have them pretty quickly. They can just do, like a slotted operation, and they kind of feel it with their hand. They'll feel the cutting going on. And then I've had, a kid where he went too fast, and we had a piece of aluminum in there, and they grabbed the aluminum and it ripped it out of the vise, which was kind of cool, but they learn. And so you're right. You got to start with the manual. I think I agree with that. And then they graduate into the CNC. You know, I wonder if Leif does that, if he starts them on manual. Or
I love, and then I like the I had actually heard that project before. I think it was Adam that also said the little brass hammer, like machine hammer, because you use that, and somebody, I think he might have done his with like a wooden handle as well, so just a little more simple, kind of, you know, without doing the threading. So that was like, but I like that you could do that entirely conversational. But so we're looking to go a few areas. We still do the robotic stuff with the Shell Eco Marathon, even like building a little spindle or something for which I think it could be helpful for. But then we just want to get a small project like the pliers that every kid can do. You know, every kid can leave there with a trinket that said, look, I CNC'd this, and they can kind of run it through. Maybe it just, you know, most of the file is done for you and you just add some piece of customization to it or something. So I like that stuff a lot. And I think that's just again, like you guys said, you know, just get the kids out there doing it. And then some of them will bite on and run with it. And that's awesome.
So let me just point out, this can come installed. It'll give you your X and Y, not your Z.
Yeah, that's awesome.
Dude, it's good.
Yeah.
And the kids get it right away. It's just your, you know, display, and it'll come with that machine.
Okay.
You know, like if you have, Mark, we'll get you this one second. And it'll come with this machine. It doesn't show it here, but it'll be installed.
Okay.
It's like, dude, you just engine hoist it onto the platform and you're ready to go, man.
Cool.
Yeah. You know, you just gotta like
a little more. The CNC is a little more than that. that one took.
Yeah. And I knew that going into it. So when the principal was talking to me about this, I was like, dude, it's got to come with training and installation. I can't make a project out of this. I want to do it. I want to do it right. And so that's why part of the reason we're doing this conference, I'm sure I'm not the only one. And it sounds like Richard, David, you put the cart before the horse. And we're trying to fix that now.
Well, I'll tell you another funny story too. I'm sorry I ramble, but I got a kick out of it because I just, with my old supervisor, Jim Novotny, if you knew him, this great guy, just legend in tech ed and involved in everything, you know, tech ed. But the funny part was we're good friends still to this day. And he's when we had this funding, I really wanted a CNC plasma table, and he wanted this mill. And he was big with the robotic stuff, and I was big with the shop stuff. And I really wanted this, you know, CNC plasma cutter. And, you know, he ended up getting the mill, and the thing came in, and it was the boxes that were sitting there for a little while. And I'm like, I'm not putting it together. You put it together. You know? I wanted the mill. I wanted the plasma cutter, you know. And so at first there was, you know, joking around a little bit, but there was some contention with it. And then finally, when we started putting it together with the students, we just had a blast just putting it together and, you know, following through the directions. And they had a lot of ownership over the machine too. That first group, that's when and then I also had a former student come back who works for like Jack Tool, you know, good company. And he came back and ran a whole bunch of stuff for some of our projects that we were doing. And that was pretty cool. He was used to using it on a regular basis. And he, it was really nice for some of our students at the time to see that just somebody like working this machine to its limits, you know, much more than we were comfortable with. So that was pretty neat too.
That's awesome, dude. If I had to put together all the machines in my shop, oh my God, you're just so limited on time, you know. Anyway. So, all right, I want to jump over to Mark, but then we got Dave Potts here. Dave Potts looks like he's gonna punch David in the face. No, just kidding. I got a smile out of him. I knew it. I can tell. I like this guy already. Look at this guy. All right, Mark, what do you got for us? You got your queued up hand.
Well, the first thing I wanted to say, I like that you showed the quasi-manual operation as a way to graduate, but also as a way to marinate a new thought process. And it's also because, you know, the new machinery that's out, I hadn't played with, but all the manual stuff I have. So I understand that level to get there. But I was stuck on a point, and all you guys seem to nod along, but I didn't know. Jenny, you said there's something called the Mill Show, and I don't know what this is.
The
Didn't,
mill.
didn't you say you guys sponsor like the Mill Show or something like this?
Oh no, First Robotics. The machine shop in First
Machine
Robotics.
Shop. That's
The
what it
machine-
was.
Yeah, so when they're doing the competition, like at globals or at regionals, if the students, like if they're climbing a ladder or rope and the robot falls, they have to get their robot functioning before the next and I'm probably there we go, First Robotics competition. So it's kind of like no, I'm not going to say it's kind of like BattleBots. It's nothing like BattleBots, but I love them both dearly. David's smiling because I'm sure he I love BattleBots. I mean, Ray Billings is like the coolest guy ever, and I have some really fun, embarrassing stories that I could share with, hanging out with him. Embarrassing on my side. But he's awesome. But with First, it's kind of this cooperation. The kids are helping each other. But like when they're in competition, if something breaks, if a gear strips, if an ear, the gearbox, if something happens to the robot, they need somebody on site who can machine the part so they can get it back on the robot and get back on the field. It's fun and exciting. So
when is the next show?
So they usually get their reveal. So, and I don't know, David, you're kind of probably more involved on the mentor level, are you? Or with First Robotics?
I'm actually the one that we do is FTC is the middle one.
Oh,
so we have
okay.
about 4 teams for that, and we don't do the big ones. So we already had our reveal, we had everything, so the teams are off and running. They had some small competitions, so that one was kind of neat because the kids can entirely build the robots, so that's what we liked about it. Whereas we didn't have a big enough machine shop to kind of send the kids off to do their entire robot themselves. So we like this concept. And then instead of doing this, the bigger one, we do the Shell Eco Marathon, which we're kind of teaming up with Ron to get going as well, which is another cool competition, building a car as well. So a small car prototype.
Listen, let me interpret for Mark. It's basically WWF for robots. You can there's definitely some body slams going on. There's it's a good time. And it's filled. The stadium's filled. You're like,
oh yeah.
You can't believe how popular it is.
Dude, it's like being at Lambeau times 10. Because I mean the kids are dancing and cheering. It's an adrenaline rush.
Yeah, it's wild. So basically, it's kind of like it's like a throwback to back in the day, like this. It was like the Survivor series,
Where's
yeah.
There we go.
There we go. Macho Man, Randy Savage. There's a person with a microphone. There's talking smack in the beginning. There's definitely like an arena. It's just like this. It's no different, Anyway, I know it's funny. But Dean Kamen, that guy created it, and so the guy who created the Segway, he's like a super nerd, and he's like, you know what? Why don't we make this more like sports and combine the idea of sports with robotics, and then that's what happened, Let me jump over to Dave Potts. Dave is how you doing, Dave? Where are you coming from?
Exit 7.
Okay, all right, you're down the shore, man.
Yeah, well, no, on the turnpike. So we're over by the river. So
okay.
in fact, Kevin from your school last year is at my school now.
Oh, no kidding.
Yeah. Yep. Yeah.
Kevin Witt.
Yes, exactly. Yeah.
Oh, dude, wait, you work with Kevin?
Yes, I do.
I knew I knew your name somehow. That's amazing. Oh, thanks for joining us.
No, thanks for Kevin.
Wow, dude, that guy's great wherever he goes.
Yeah.
We were glad to have him for the time he was there. We got a new sucker, teacher, and
Yeah.
You know what the thing is, dude? That commute must have killed him. It was from Rutgers all the way up to basically almost New York City. You know. Like,
Yeah.
so
He said he's saving $2,200 a year and is just tolls. Yeah.
God, it's insane.
Yeah. Hey, I'm glad you talked about using wood as a material. I'm teaching metals 2 class first time in 40 years as a shop teacher. And one of the projects we're going to be doing is a turkey call on an old school milling machine. It's a Bridgeport clone. So we'll be cutting that pocket out of I've got some sassafras all lined up. And then the kids will design the sliding lid on it. And laser grave their name on that and end up with a little turkey call they could take home. We're kind of rural where we are. We have a lot of farm kids, ag kids, and ag program. So it's tailored to our kids and to our school. And it's a good way, a forgiving way to get them to use the mill, and work with, all the things they need to do with that before they get into some metal.
And they're a lot more comfortable with wood, right? So it kind of allows them to relax a little bit.
Yes, exactly. And more forgiving. Like I said, it's not going to, break a mill. The tooling's going to last a lot longer. And we're just going to have a kid with a shop vac, picking up the chips. So, and no cooling involved. So that's not a problem.
Right.
Yeah.
So I teach in an urban neighborhood, and none of my kids would know what a turkey call is. And I'm part urban and part suburbia, so I don't even know what that thing looks like. Let's take a look.
It's a box. This is a box call, and then it's got a lid that swivels. And as you swivel the lid, it creates a harmonic pattern.
Is this what it is? Is that it?
It's not shared yet.
Oh, my bad. Sorry.
That's okay.
Sometimes I forget the presentation. Yeah. What do you think of this? Oh, I shared the wrong one. Oh boy. Here we go. Okay.
Hey, that's my turkey call. That's it.
Is it? Oh.
Yeah. Well, it's just like that. Yeah, just like that.
So you're going to cut out the pocket on the mill?
Yeah, the pocket will be cut out of the mill.
That's cool.
So, yeah.
Nice. And
so did you program it by hand, or did you use like a conversational?
It's a strictly a hand mill. Strictly a hand. It's an old school Bridgeport. So, yeah. A Bridgeport clone, let me say. So.
And how does it call? Where do you put the air? Like
there's a board that goes on the top, and you swivel the board so you don't blow into it. It's just creating a noise from harmonics, kind of like an acoustic guitar would, with the strings on top. But this is a board on top, but there's a little bit of friction, and it creates like a warble.
Kind of like New Year's Eve, the little, I don't know, maybe this is dating me a little, the little ratchet.
Yeah, but instead of that ratchet, it's just the friction of the lid on the wooden body.
Wow.
Kind of like a rosin on a bowstring, on a violin.
Cool.
Put a little chalk on it, and it helps resonate better.
Exactly.
I can do that at Maker Camp next to Nick's booth next year.
Yeah, that's so funny.
So is there like a tech ed repository for all these awesome like projects where you guys could share them? There should be. Well, we started a forum. I'm like, shoot, you guys should because
Shop Class Podcast. This is where it happens.
We have the drive, the tech ed drive that we have.
Yeah, we've been dumping stuff into a drive. And then Leif has a really good website, believe it or not. Just look it up. He's got some good stuff going. And now, David Potts, are you going to do I know Kev is real good at making jigs. So for production, so everybody just follows the steps. Is that how you're going to run it?
Probably not. Because they'll have a set of blueprints they follow, and it's just a matter of getting it clamped in the machine on the table. And then the rest of it will just be cut to size. But they're all going to be basically sort of standard. And it'll be the lid design they get to really do their one-off on their own image design. So
okay. And what do you do about maybe you could tell me some of the, getting into the weeds a little. how do you get it so it doesn't tear the wood and it actually cuts the wood? Does that have to do with speed, or is that the type of cutter?
Exactly. Yep. It's a speed and a sharp cutter. And for a mill, it's actually going to be a little higher speed, not a low speed. So it's not the kind you think you want to do all the time. You can do this you could do this with a CNC router too, like a shop bot.
Pretty cool. This is awesome.
Yeah.
All right. Nice. Well, this is pretty good. Now, David, are you gonna get into some pots? Are you gonna get into some CNC? Do you have a CNC machine at the school?
We have a shop bot. We don't have any in the metalworking area.
Oh, okay.
And I think this is my last year here. This is 42 years for me. It's time for me to turn the page and get a new chapter.
So lazy. I can't believe you're quitting so early.
No, I'm going to another page. So that's it.
Go at least 80 years.
Yeah.
That's amazing. 41 years.
Yeah.
The guys like you, you're the glue of the industry, for real. And we got to give a shout out to you because programs. You survived the 90s. That means.
Yeah, and actually, we had a riff in the 80s. I taught computers for 4 or 5 years, and we had some shop teachers retire then, and I got a chance to move back. Programs were slim then.
What was that like when they were trying to kill programs? And the younger guys. I mean, I've been doing this 18 years, and so we're kind of in the young division here compared to the 41. But what was it like having people tell you that you needed to get rid of your equipment and kill shops? And what did you have to say about that?
It has been a battle even to this day to try to preserve some things. We had shops that were shut down. Like we lost an electronics shop. They said, you don't need electronics anymore. Our auto shop closed down. We converted to engineering. So that was a good thing there. But we weren't able to recover the electronics. So I actually grabbed a lot of the stuff. I'm still using DeVry power supplies that were from when I was a kid at the school in 1970, 75 or 74. I sent a picture to my shop teacher. He's out in Western Pennsylvania now. I said, look, I just pulled these out of the closet. We're using these for some LED lights my kids are making in my engineering class. So
what's amazing about this? The story is the same across the entire United States. Guys like you save shops by hanging on, like hiding the equipment.
That's it.
There was a shop teacher. Did you know Mr. Canito?
No.
Okay, well he's up here and you're down there. So but anyway, Mr. Canito taught for 41 years and he just retired about, it might be almost 7 or 8 years, maybe 10 years now. But anyway, he in the 90s, he had to hide lathes in the closet and hide the equipment and hide table saws and all kinds of stuff when the scrap metal guy came around to scrap it. Meanwhile, they were selling it to make money. And and then later he pulled the stuff out when that terrible wave passed. And it's amazing that these shop teachers like yourself save programs by hanging on and making it to present day where the young kids have a chance, because of course you could just buy new equipment and whatnot, but what about all the skills that have to be transferred down? And then what about and you can't just buy it, you can't buy everything, you need some old equipment there as anchors to kind of as an example.
Well, with a lot of machines like for instance a drill press, an old school drill press was built really well compared to something you buy today that's new. Between the chucks falling off and rattling and things like that, that wasn't a problem with the old drill presses. But with the new ones, you had to spend a lot of money to get that quality, or they're not available anymore. So
yeah. And like you said, like once you lose a shop, it's not coming back. It takes an enormous amount of effort to bring a program back.
Right.
Yeah. Well, so hats off to you, man. That's awesome, man. I really appreciate you. Your years of service.
Oh, I'm just doing what any other guy would do. Same as anybody here in this group. So,
Dave, you need.
I don't know, man. 41 years is a lot. I can't even imagine.
Dave,
it's been fun though.
You need to come back on. You need your own shop class podcast episode.
Yeah.
Yeah, man. Let's do a profile on you.
Thanks.
Yeah, no, and you're humble, I could tell, but for real, we this is it's not usually a big round table. We usually do a profile on someone like, hey, did you have shop class growing up? What was it like? What'd you do? How'd you get to where you are now? Tell us some highlights. It's kind of fun. We do like a whole profile on your career.
Right.
Yeah.
I actually owe my career to mentors like yourself and teachers like myself. And most of the folks that I learned from were in the industry 30 some years. And when I started, I was in my 20s, little snot-nosed kid, you know, and I mean, just all the stuff I learned. And I learned more, I think, because I was forced to set up an advanced turntable, because I was forced to use a Bridgeport. And even though I knew CNC, I'm like, oh no, I want to run it on the CNC. It's going to be a lot faster. And he's like, yeah, but you're going to learn a lot more if you do it this way. So.
Right. Yeah. And I hear back from kids a lot of times where they have an industry change. They go back to what they really like. That's what we did in class, 20, 30 years ago.
Yeah.
That's cool.
Yeah.
Well, it's getting late, but let's jump over to Andrew for a minute. Andrew's here. How you doing? I was always surprised people were like probably chilling out, and then I hit him up. Andrew's great, man. He's an award-winning teacher. He's up in Rockland County. He does a lot of metal work. He's got his own shop as well. Do you do any CNC work? I know you do have CNC plasma, but do you have any three-dimensional stuff going on?
We have a Bantam Tools. We have that little desktop one. So the problem with my shop, even though I now have a Bridgeport, when I first started, I had one bus garage bay. So I couldn't do anything really. They got a grant when we started the program. And so I had to buy a lot of small stuff. Just because that's the only space I had was one bay. And then we took over the other 2 bays. So we have 3 bays now. So when we won the Harbor Freight Tools for Schools prize, I was like, all right, let me go get a milling machine. But luckily somebody in the community wanted to donate a couple tools, and one of which was a lathe and 2 milling machines, surface grinder, which was pretty much scrap, and some other tools. So I was like, instead of spending 18 to 20 grand on a overseas knee mill, I was like, I could get a free Bridgeport, so I'll do that. I wasn't really thinking of like CNC milling machine for my class. The reason why, like, all I'm going to use my milling machine for essentially is to really like rip the back of our bend test off. So when we weld, we do an AWSD 1.1, and we have to rip. There's a backing strip that we have to cut off, and we have to either grind it off or use a saw or something like that, and then grind it so that when we can bend it and do all that, check the welds destructively, for them to get certain certifications and stuff. So the reason why I went with why I was going to go with a traditional manual machine, like some of you have said, is like, if they learn how to run a manual machine, it's easier for them, maybe not easier to transition to CNC, but they know the basics of how a machine works. So if they want to pursue that, then they still can. And that's why I went with the Bantam Tools. They're actually like right across the river from us. So like customer service and stuff is like really easy, because they could just, one of their people lives over in Rockland, so they could just send somebody over. But like the footprint, once I got the Bridgeport, there's no space. I don't have space really for the Bridgeport. I made space for it, but everybody here needs a bigger shop, but we all have the same problem. So yeah. I mean, it would be nice to get CNC, but problem with some of my students is it's a welding class. It's not engineering. It's not CNC. It's not mechatronics. It's not any of that stuff. It's welding. So one of the reasons why I got the Bantam is because it's small enough. If I get a student like David was talking about that just took welding to get out of class, and they actually wanted to take CNC, or they're into robotics or something like that, then they have an outlet in my welding class to pursue something that they might enjoy more than welding. So that's it. Yeah.
That's pretty cool.
Yeah, so they came out with a new one, so it's even fancier than mine. But yeah, we got the first one.
It right here.
Yeah, that's the one we got. Yeah, I think that's the one we got. Yeah, they have one with the screen on it and now and everything. Yeah. But that's the one we got. We don't have that adapter yet, the 4th axis. We don't have that one yet.
Wow,
But
look at that. That's pretty cool. Interesting. Yeah, it's an interesting thing where it's like it's like a 3D printer.
yeah, kind of. It's almost like a router, somewhat, for metal in a way. Like it's a milling machine, but it's it's very compact, and again, for the footprint that it takes up and the benefits it provides, it's like perfect fit for our class. If we had more space, then I would just go bigger, but no need. So
Yeah. All right. Cool.
yeah, but I've also found that there's some places in North Jersey looking for CNC people as well. Like we tried to get a kid out on internship last year, but the shop got so busy, they were like, we can't take on somebody to train right now. And I'm just, as teachers know, we're just like, well, then you're going to be out a future employee. Like, if you're not willing to train them now, then you're not going to have them later. They don't see it that way, though. So
Interesting. That actually leads me, yeah, that's okay. That actually leads me to a question that we could probably wrap up on, which would be, what if a student wanted to get into this industry as for machining, where should they focus? Like, who is sucking, like, where's the magnet for all the jobs going? Like, who's the biggest employer, or what area is employing the most? Does anybody know the answer to that? I feel like Jenny knows.
Do you want my, okay, this is my opinion. I don't have any analytics, but I can tell you trends being in this industry, because I get asked that a lot. Where are all the machinists at? Where are all the machinists at? Where are all the machinists at? And what I tell them is a lot of the machinists are doing what I'm doing, chilling in my shop, and I'm working for Tormach, but a lot of machinists are buying like our equipment, starting their own business, because cottage industry allows a lot of flexibility, and larger companies are starting to contract out to the small man shop. And what I mean is like the guy who's over here, because when you think about it, when you look at industry, when they hire a machinist, and you're talking benefits, training, everything else, you're looking at like $20,000 to $30,000, $30,000 just train them. A lot of machinists went and have started their own shop. So a lot of the students, I know more 18-year-old entrepreneurs now that I'm just floored. I have a lot of customers that are like, hey, I'm graduating high school in the spring and I'd like to start my own shop. And I mean, these kids are working, they're working a lot, it's kind of a unique time. I don't know what it's like on your coast, but I know here we have a lot of programs where the students can actually finish high school or finish with the tech degree when they graduate high school, where, there's, I don't know, is that something you guys have? But as far as like industries that are hiring the most right now, aerospace, technology. So, and I'm talking about, they need machinists to make casings for, switches and controls and that kind of thing, and automation. End of arm tooling right now is huge, because as they're automating the production floors, someone has to make the parts for holding for robotics. So I don't know if you guys are seeing the same kind of thing.
I can also chime in. We live in the pharmaceutical capital of the world. So we have a tremendous amount of machinery. All the production line stuff is custom machining. So I have some former students that are in the pharma industry. And then I have a lot of former students in the defense contract, under defense contractors. So like Jenny said, with aerospace, but also just kind of, we have Picatinny Arsenal, which is right by us, which is basically, huge military research facility that does a lot of custom machining before they go into mass production. They're doing a lot of their R&D stuff. And then, but yeah, just I mean, I think all forms of industry, but certainly those are the ones that we tend to see a lot of around here.
And I think the answer is going to be regional, right? Depending on what hub you're in. Are you in, like we're in the Midwest, or where I grew up, and medical was a big one, but mold making and that kind of thing.
Yeah.
Plastic injection molding for us, printing for you guys. So, and I'm sure if you go somewhere else, oil. And I don't know where they're at with oil, but if you're in proximity to where they're doing it. So I think the answer, honestly, is going to be a regional one.
One of our real neat ones was some of the extreme precision stuff, which I thought was really cool too. Like, we always love seeing these huge chips flying off of engine blocks, custom engine blocks, and all that. And I think that's amazing. But with the pharmaceutical stuff, it's like on a microscopic level. I mean, you'll have these massive CNC machines the size of this room just to be able to get, I don't even know what kind of tolerance you guys, probably know, but to be able to kind of do things like divide up cells and whatnot. It's pretty cool just on such a microscopic level, CNCing out these little, devices and stuff.
And a lot of them are implantables. So you're talking like stents for veins, a medical or a medicine delivery devices for like in eyes. So I actually, before I came to Tormach, that was my world, was mold making for it. So the molds were very big, but the parts were very small. I learned a lot about materials too. So
did you work in injection molding?
I was a tool and die maker. And so I worked for Phillips Medisize, which I believe they also have East Coast location, and Scientific Molding Corporation, which also I believe has an East Coast. It's been a long time. I mean, I've been at Tormach for a while, but so mills are my favorite machine, but I've done mills, grinding, fitting, EDM, whatever I needed to do, programming. I spent a stint program. I just don't sit still very well. I have an elliptical machine. So if you see me bouncing, I was one of those kids that learned with my hands. And so, I mean, like machining, it keeps me kind of sane too. Because I don't think I could stare at a computer all day.
I think, like I said before, I want to reiterate, you'd be a great influence on my students because it's hard to get the girls to take the classes, and a lot of the guidance counselors, they don't really push the girls to do that because they don't picture themselves doing it. But I always try and convince them to do it, and then when they come to the class, some of them not sure what to do, so they treat it like a study hall until they finally get engaged with, let's say, welding, or in this case, we finally have machinings. But believe it or not, just if you had some videos going, I would totally show my students that, because we need all the help we can get as shop teachers. And maybe as we're talking about this, the topic was in this last segment was where the industry's going and where to steer our students. But maybe you're the one who could do it because you're in the industry, and you're talking to shop teachers here, but we need the industry pros to talk to our students. So Jenny, I'm sorry to put it on you, but
yeah, I don't mind being the go-between. Well, I've done both because I'm passionate for education, but most of my career has been in industry. I just am very passionate about it because I know that I had really good mentors growing up. None of them were female. They were all male. They just all tolerated me really well, especially poor Jack, because I used to call him Dad all the time. But I think like in order to get women, like young women involved in the industry, I think they need mentors. I think that, you know, and I think not just like somebody influencing them on YouTube, but somebody that can talk to them, like a network of other women. And this is not my idea, but I want to pitch this because I met a woman who used to work at Gateway College a couple of years ago, and she had an event last month, and I went down there. It was incredibly powerful. It was young women and older women like myself, just talking about like just real talk about being a woman in the industry. And it's amazing how much crossover and all our stories there were. But she's just launched a nonprofit and I love it. And I'm so excited about it. And the acronym is GITLIT, Get Lit. It's girls in trade, ladies in trades, but come on, get lit. It's amazing. But I do think, you know, for young women in high school, it'd be great to have a place where they could talk to women who are actually in the industry and ask them actual, like, not parroted questions or parroted answers. You know, people like, oh, I love my job. It's great. But I mean, like actually having a conversation about like all the different avenues there are in the trades and how to really get them involved and, you know, things they might see, but things that we can change. So. Oh no, I'm in Wisconsin. Actually, it might be. Let me see if I can find it. I feel so bad. I can find where my mouse went. It's on one of my screens. And I don't know if she has a website yet. It's relatively new, but
okay.
she just did a. I'll see if I can find it and throw you the link.
Yeah.
It sounds like the lady that you went and worked with in California, Ron.
Yeah, there's Tiffany Von Orff. She's a welder, and she does structural welding, and she taught it for a while as well. And now she's starting a exploratorium, she calls it. It's basically a workshop where, you know, everyone's invited, but it's a female run, you know, trade shop that teaches welding and machining and automotive and some custom car stuff too.
Really? See, and we need more of that all across the disciplines, I think. And it's not a down at the patriarchy thing. I always hate when people are like, oh, you're one of those feminists. I'm like, no, I'm a STEMinist. I believe that we need.
It's all good. It's just, it's not complicated. It's basically like if you're a girl in a class and then there's this cool girl who's in the industry, you're going to feel an attachment. It's not like, and the same thing, like I'm a dude and I see a guy on a motorcycle building motorcycles. I'm like, oh, I could be that dude, you know, like it's not extreme anything. It's like, we just need influences and mentors, like you said, you know? So let's see. Here you go. Right here. The Welding of Women Syndicate. This is it right here. And she does an interview like once a week. So she does these things where she was at SEMA and she builds cars. Tiffany Von Orff. And all of these reels are like the long form interviews. And then she also has, let's see, if you go back here, then she has the Exploratorium, which is a new venue. And that's where she teaches all her welding classes and whatnot. So pretty cool. Anyway, yeah, go ahead. Sorry.
Oh, I just said that's awesome.
Oh, yeah, yeah.
We have I'll have to get you, because the woman from Kenosha, see, we just need to get all of us together. You need to have you know, roundtable discussion. I'll bring my gals, you bring your guys. No, but we're all, I mean, I think the thing is, it doesn't matter. Gender doesn't matter, because my dad used to say, growing up on the farm, I was always out in the field with my dad wearing my Oshkosh Bagosh striped bib overalls. And my husband does the cooking and I do the, you know, changing the rotors out in the car. To me, that's not weird. But to some people, they're like, that's weird. How did you get into machining? I'm the same. And I'm like, same way everybody else does. And people are like, but I'm confused. And they're like, is it harder being a female machinist? And I'm like, no, because the machine doesn't care that I'm a girl. as long as I put the right information in, it's going to work just as well for me as it does for anybody else. And the way I was brought up is my dad's, I'd be out fixing the tractor with my dad. And he's like, the tractor doesn't care who fixes it.
Yeah.
As long as you know what you're doing. And even if you don't know what you're doing, sometimes you get lucky, right? So
That's great. That's a good way of putting it. 100%. The tractor doesn't care. I love that. That's cool. Yeah, it's open to everyone. So
yeah.
More timestamps in tonight's than I think any timestamp yet. This is like a hoedown of timestamps.
yeah, I've been breaking it into chapters. So once this is done, I re-listen tomorrow while I'm at work, and then I just I put down all the things so you can click on it. All right, well, let's wrap it up. This was awesome. I do feel like I learned something about setting up the machine, and I learned about the ups and downs and the materials, and I got inspired, and I got to meet some people. We got to know Jenny. We got to know David. We got to hang out with David Richards as well. Mark Willie's in the house. Andrew always jumping in. Thank you. Nick's here, and Duke. This is awesome. What a cool thing. And then Leif gave the whole demo. That was pretty cool. So this is a good episode. I appreciate it. So we're going to end the recording, and we usually just kind of hang out for a minute or two, but that's getting late. So, all right. Thank you so much. Shop Class Podcast. See you on the next one. Oh, and next week is Thanksgiving, so we're going to take the week off. Okay. Manage the recording and end it.